the bivariate transformation of random variables. So to consider the bivariate transformation of random variables, we have two random variables x1 and x2. Both are continuous random variables with a joint PDF f of x1, x2. Now we might be required to find a transformation of these variables into another variable. It may be, suppose, like x1 divided by x1 plus x2, or simply x1 plus x2, or anything so. We are required to find these transformations. Suppose we are required to find these transformations. So I can write this is equal to y1 and I can write this is equal to y2. So you can see that this y1 is equal to x1 divided by x1 plus x2 and y2 is equal to x1 plus x2. So I can write this y1 to be a function of x1 and x2. So I write this as g1 of x1, x2, and I can write y2 is equal to another function g2 of x1, x2. So that is what I have written here. So x1, x2, with two continuous random variables with a joint PDF f of x1, x2 on A, and we are going to find the transformation, or we are going to find this y1 which is equal to g1 of x1, x2 and y2 which is equal to g2 x1, x2. So generally this y2 or y1, any one of that, is considered to be a dummy variable that makes us easy to find the transformation. And we also assume that these two, y1 and y2, can be solved uniquely for x1 and x2, as we can write x1 in terms of a function of y1 and y2 alone, which I denote by h1 of y1, y2, and I can write x2 as h2 of y1, y2. So in this way is how we choose this dummy variable y2, and one might be our required question. Now we require to find a Jacobian. So a Jacobian is denoted by J, which is equal to the determinant of a matrix. So here it is a 2 by 2 random variable, because here is a 2 random variables, the bivariate random variable, which is being transformed to a y1 and y2. So we have 2 random variables that has to be transformed to another 2 variables, y1 and y2. So it is a 2 by 2 matrix. So we are required to find the determinant of a 2 by 2 matrix. So we are required to find dou x1 by dou y1 and dou x1 by dou y2, dou x2 divided by dou y1 and dou x2 divided by dou y2. So this is the matrix of Jacobian transformation. So Jacobian of the transformation, which is denoted by J. Now what we are required is, we are required to find the joint PDF. So we can denote that joint PDF as f of y1, y2, which is a function of y1 and y2, which is equal to the original PDF that we had, that is f of x1, x2, comma x1, x2 in terms of these y1 and y2 into modulus of Jacobian. So one thing to note here is this modulus sign. This determinant might be a negative 1 and it can be a negative 1 too. So the determinant are not always positive. So what happens here is, here we are going to take the modulus, just as in case of univariate case. So this is the bivariate transformation of random variables. So we are required to find the transformation of y1 and y2 in terms of x1 and x2. So in order to find that, we have a PDF, that is the original PDF, that can be written in terms of this new random variables y1 and y2 and multiplied by the Jacobian. Multiplied by the Jacobian. So Jacobian is the determinant of this matrix, the modulus of the Jacobian. So this is how we are going to find the bivariate transformation of random variables. I shall explain the Jacobian using an example that we have already taken here. So we are required to find a transformation y1 is equal to x1 divided by x1 plus x2. So this is the required thing for the transformation. So this may be the question, what is the distribution of this? So in order to find the distribution of this, I had taken y1 to be x1 divided by x1 plus x2 and I had taken y2 to be x1 plus x2. So this is my choice of y2. Now I can find x1 and x2 in terms of y1 and y2. From here I can write, we have these things, y1 is equal to x1 divided by x1 plus x2 and y2 is equal to x1 plus x2. So substituting this in this, I will get y1 into y2 is equal to x1, isn't it? So I have substituted instead of this x1 plus x2 as y2. So x1 is equal to y1 y2. We have got x1 in terms of a function of y1 and y2. Similarly, on resubstituting this x1 in this, I will get y2 is equal to y1 y2 plus x2. So from here I will get x2 is equal to y2 minus y1 y2. So I had written x1 is equal to y1 y2 and x2 is equal to y2 minus y1 y2. So instead of h1 of y1 y2 we have y1 into y2 and instead of h2 y2 we have y2 minus y1 into y2. So from here I am going to find the Jacobian. So Jacobian is equal to determinant of, I am required to find dou x1 divided by dou y1. So dou x1 divided by dou y1 will be y2. Similarly, I am required to find dou x1 divided by dou y2, that is derivation of this function with respect to y2. So that is y1. Now I am required to find the derivation of this with respect to y1. So this is y2 minus y1 into y2, which is the derivative with respect to y1 is minus y2. Similarly, I am required to find the derivative of dou x2 divided by dou y2, that is the derivative of x2 with respect to y2. So that is 1 minus y2 divided by dou y2, that is 1 minus y1. So I am required to find the determinant. So determinant is equal to y2 into 1 minus y1 minus y1 y2, and there is a minus, this minus symbol. So which is equal to y2 minus y1 y2 plus y1 y2. So this is the Jacobian that we have obtained, y2. So what will I be doing? Instead of this j, I can write it as y2. And I can write f of x1, x2, x1, x2, x5. This PDF in terms of this y1 and y2 into multiplied by this value. So this is how we are going to do the bivariate transformation of random variables.